Welcome, welcome. Everybody's comfortable. Wonderful to see you all here. Aloha or hola, bienvenuto, depending on which way we're heading. Okay? We're talking about satellites because satellites are everywhere and impact our life. I was out walking with Captain Eric today around the ship and couldn't think of anything he was doing that wasn't related to satellites. The weather satellites, which help him navigate and figure out the best path to go. The communication satellites, which allow him to maintain contact with everybody. And then the communication satellites that help you contact your family and friends. And how would you feel if there was no contact? You would not be very happy if you couldn't talk to family and friends. And we've got so many other things that the satellites do in our lives. We are tied intricately with the satellites. So what I'm going to share with you is a brief history of how we got here. And we're in the rocket age, so we were there in '69, right? We saw things happen. Well, we'll zip through that a little bit just to remind us, and then show you some new aspects about the satellites that you might not have known, and some new applications, and some of the big players, and why we care. Because there's a lot happening, and it truly is fascinating. I'm always entertained and enlightened by what's going on, and so spend a little brief time with you and share with you my ideas of why satellites are important. So when you look up at the sky with your grandchildren and friends, you can impress them a little bit. So again, a lot of you know my background. I spent time at NASA, and so that helps inform me a wee bit about the satellites. And I made a career using satellites to monitor the planet, and in that application, including Google Earth, which is one of my more proud moments, all based on satellites. So, proudly standing there in Johnson Space Center next to a big sign. And again, the cruise directors appreciate your feedback from the entertainment, from the education enlightenment. And when you ever get the chance to talk to them, let them know how you feel. That's their feedback. All right? In our lifetime, we have absolutely blown past the original. From when we were children, nobody thought about this. This is not the way they viewed the universe. And we see it now, and we almost are complacent about it. But as we look around, we see a lot of little swirly things, and those are galaxies. Those galaxies, as Carl Sagan explained to us, billions and billions of galaxies. And if someone had showed that to us when we were in college, we would have said, "You're kidding, that doesn't exist." Those are 3 galaxies all getting ready to interact. And we go, wow. So how do you put your mind around that when you go, I wonder if there's an Earth in there? I mean, we don't even know if there's other Earths in our Milky Way galaxy, and here's galaxies and galaxies and galaxies. So mind-boggling changes in the way we view the planets, the universe, and I'm always humbled to remind ourselves, we might know 5%, maybe. So the unknown is still spectacular and offers us so much promise for a never-ending story about the universe and our life in it. And any field that you pick, it's all happening here. And so we're out there in a spiral galaxy. It's about 100,000 light years across. So if you could travel at the speed of light, you wouldn't get out of the Milky Way galaxy for 100,000 years. Swirling masses, black holes in the middle, still don't know what's going to happen. Is it going to suck up all of the galaxy someday? We're not really sure. We don't know. We're just cruising on the edge of this one in our little blue marble. We've talked about the ocean world that we live in. It's a spectacular world, and we can thank our friend astronaut Bill Anders for helping us understand a little different perspective about us, our planet, our universe, back there, Christmas Eve in 1968. Seems like only yesterday. Now, there are many wonders out there, And I'm going to show you one in a second. And I just want you to ponder the next slide. Is that real or photoshopped? That's real. That's a real photo of the fastest Tesla in the universe going 44,000 miles an hour, okay? That's a real picture. Now, I'm sure that Elon Musk wrote it off on his taxes. You can donate it to PBS or you can donate it to the universe, but it really is there. And he's playing David Bowie's Starman in the music in there. So there's a lot of details in what they did when he launched it off of a SpaceX satellite. It's amazing. And should you want to know where that Roadster is today, you can go onto Tesla Roadster Space and look at its live position in between, Earth, Venus, and Mercury. Now, how do you put your head around things like that? To me, it's a bit of a challenge sometimes. But someone ever wants to bet the fastest car, right? Now you know, and you can win that bet in any bar very fast because it'll show you orbital speed, 44,929, 45,000 miles an hour. Phew, that's fast. And it's electric. So, there you go. We think we know about it, and we keep going. Mind-boggling facts and actions and progress. And why is it mind-boggling? We owe mind-boggling a bit to a guy named Gordon Moore. And Gordon Moore showed us that computation, and I know in this crowd, some of you have seen those cards back there when we were in our scholastic youth, and the vacuum tubes that we used to go to the 7-Eleven and to fix our televisions and things. So we've watched that growth. We lived through it. And yet it's speeding up. It's not slowing down. As fast as all this happened, folks, it's speeding up. So it's very difficult sometimes to put our minds around the speed of what space age has provided for us. And if we look at Alfred Nobel, and he did not receive a prize for this, but he shot up and took one of the first pictures ever of the planet. So a satellite taking a picture is what he did. It was a rocket, so it wasn't orbiting. Later on, Wernher von Braun. Anybody seen that movie recently? Right? About the atomic bomb. Werner was working on that team. We got a smart German, came over, taught us about rocketry. And so when I was born, that's the view of the planet over white sands. So spectacular new perspectives about our planet based on rocketry and that whole space age, rapid growth. Now, I know where I was. Do you remember where you were in October 1957? How many people remember looking up and seeing that? All right. I was in Denmark, and I remember I was a 7-year-old kid, and my older brothers and sisters said, "Watch this." I'm glad they did it because I have the memory. At 7 years old, I wasn't the sharpest knife in the drawer, but I remember seeing that, and it was fantastic. So that, what did that do to the United States? We got real nervous. That launched all of the United States together, unified, because we weren't going to let those Ruskies, those red Ruskies beat us, right? And that was it. I remember the terms. So we went out and started doing creative things. Corona, which if I had showed this to you in 1960, they would have taken me out and shot, because this was the super secret keyhole system. Keyhole was the code word for this. And it was so advanced, they took pictures of the planet, took the film, and spit it out. So the film canisters were spit out to the earth, and the Navy had these airplanes that came by and captured the film as it came down in a parachute. This is the technology we had back then, folks, and that's how we monitored what the Russians were doing. They would run back in, print the film out, and see what was going on. So the Corona satellite, the keyhole system. So we've moved ahead just a wee bit. And in that progress of how to picture the Earth, we've always taken photographs, and including the Bavarian Bird Corps, And if you look on the edge, you can see the wings. They actually use these in wartime for the pigeons. So we've used a lot of different vehicles to monitor the planet. And of course, Wilbur and Orville, once you're up there, you start taking pictures. It changes your view of the planet. So they went up there, started taking pictures. Remote sensing, big time, World War I, they said, yes, we need pictures. So the idea of being able to map and take pictures of the planet became very popular. And you might remember Gary Powers, who embarrassed Dwight Eisenhower, because Dwight Eisenhower said, no, we're not doing anything like that. And they said, well, we got this guy named Gary. Would you like him back? And they said, Gary, you were supposed to take the cyanide pill. He goes, I thought about it, but I said, nah. So he died of old age. This is one of the first early infrared images of San Francisco, where the green vegetation shows up as red, infrared. And this is one of the early ones. And for those that think the Earth's flat, they're going to be disappointed. But this is one of the early U2. So a lot of things going on in the field. Department of Defense, obviously a big one. So again, I'm doing this briefly to remind you what we've been doing. Now the three key areas to think about is LEO, GEO, and MEO. It sounds like Donald Duck's kids, but you've got your low Earth orbit, and that's where most of the things are. And the space station is in a low Earth orbit. Medium, that's 3,000, 7,000, and geostationary, way up there, and it goes around at the same speed as the planet's rotating, so it's geostationary. And a lot of our weather satellites are geostationary satellites. So what's happening? Boom, we're having a space race. And it is amazing the amount of energy, money, engineering, intellect, and international cooperation that's going into this process. So if you're going to have a space race, you got to get it up there. So the basic mechanics of getting it up there are the Earth's rotating, you got to get it out of the atmosphere and allow it to go around and around and around like the moon, a satellite on our planet. Remote sensing, the way we view the planet, uses the electromagnetic spectrum, we've talked about that, giving us atmosphere, giving us planet surface information, gases in the stars, temperatures, etc. So that's why we know what we know about the planets and the asteroids and about planet Earth. Again, our friend Mr. Photon, whose first picture taken just last year, the very first one, the light goes through and it breaks up to a spectrum which provides Hawaii with its beautiful sunsets. And so we're able to understand all the different things in the air as light interacts with, because we can tell each different chemical, each different molecule that we see based on its reflectance from electromagnetic spectrum. So the light is very important. And the sun gives us, this is the pattern of the sun's light. It's a nice general area, which in the middle, that's the visible. Our fluorescent lights, and the lighting in house, both whatever kind of lighting, but here's a fluorescent light bulb, much different spectrum. And so you might notice some of your clothes look a lot different indoors than outdoors, and it has to do with that spectrum. So this is the science of light, and it has an impact on so many things. The people that master that make movies and all kinds of things. So the light, very important. And it's very important for us to understand when we're monitoring the planet with our Earth observation satellites, what that spectrum is telling us. So that's why we know what's there sometimes, and people go, how do you know? Because we're measuring it with precision, It's not a judgment, it's not a belief system, it's precision engineering. And as we go around the planet, we end up quilting our view of the planet. So for our low Earth orbits, we make a quilt of it, and when we stitch all that quilt together, when you go on Google Earth or see some of these images of the planet, it's because we have quilted that together to give you a nice view. Now, those that know about it, you can find some of the stitching sometimes. So if you get into some of the Google Earth, you'll notice there's a little bit of difference between one part of the image and the other. That's the stitching that goes on. Concatenation of the spectral image in a tessellation plane would be a nice technical term, but you can just call it stitching. So what do we have up there? We have a lot. We have a lot up there. And NASA's been investing in these for many, 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 many years, both the Earth observation and the solar observation, because everything in our world, our existence, has to do between the sun and the Earth. That's it. So everything that will affect and impact our lives is based on that domain. And you can see there's a whole bunch. The one's called Landsat, that's the one that I specialized on, the Landsat satellite. But, and I was very fortunate to get a job at NASA headquarters on Mission to Planet Earth, which dealt with these over here. I'm not a sun expert, but it's a wonderful, exciting domain, to say the least. And so our weather satellite's been up there monitoring the planet during the day. And for those that caught the show about Turn Out the Lights, those images have come from the Defense Meteorological Satellite and others that take the image of the planet at night. And so I understand they're just now getting images back from California, from the satellite at night, of the events happening over there. So the satellites are up there, but there's also stationary stations. Well, they're not stationary, rotating space stations. And those Ruskins, our buds, started in 86 with the Mir satellite, and there was a lot of our astronauts went up there with them. So there was a lot of the good international cooperation. And as a scientist, it gives me much joy to know that, yeah, there's politics, but when we get down to it, a lot of the engineering and advancements in our world and our understanding of the planet are based on international cooperation. Very important component. But these things don't last forever. So 2001, what happens when they start to sink? When they start to sink, we have a place called Point Nemo. Any H.G. Wells fans and or Disney's 20,000 Leagues Under the Sea can appreciate a place called Nemo, not the fish. But this is where they land now, because previously we didn't have a place. We didn't agree. Hey, where are you putting your satellites? I don't know. Let them fall where they may. And that was kind of the attitude. You know, it was new. How do you know? You know, it's the first time. Nobody knew to recycle their Coke cans. We just, you know, this is the way we lived. But they had that Skylab, and sure enough, they decided that since it was landing all over Australia, and it was glorious events, the night skies in Australia were pretty exciting, to say the least, to see all this stuff flaming down. And those are open up Revelation in the Bible as it happened. So all this is going on, and they agreed. They said you can keep all the souvenirs you want. So everybody in Australia went running around there collecting souvenirs, and it was quite a heyday for them. So that was Skylab. Started up there for some time. Learned a lot about life. Again, each phase of our exploration, we learn more and more. On the shoulders of giants is what Newton said, is how he achieved things, and that's what we've done. On the shoulders of the giants before. Hadn't been for Neil Armstrong, we wouldn't be doing this stuff. We hadn't been for Albert Nobel, we wouldn't be launching launches. So you see how everything builds upon each other, and we owe so much to those that came before us. Today, we have the International Space Station, which has got an incredible array of folks. And you might know Butch and Sunny and Butch are up there. They were like Gilligan. They went up there for a 3-hour tour. And they're still there. And there was Christmas. And there was New Year's. And there was... so they're up there till we get them down. So, but they've got pals. They've got plenty of people, exercise. They're doing all kinds of experiments. They're putting them to work. But they must have very supportive families to say, you know, you forgot to take the milk out. Yeah, whatever. So that's up there, and we're learning a lot, and it has a life expectancy. It's within the next 10 years, is roughly the window where that one is going to be replaced or something. But an amazing engineering feat putting all that together. And that's what the space shuttle was so important for, taking these big chunks and big parts of our erector kit, putting it together, a Lego, if you will, space Lego. And we've learned a lot from that. So we've had continued occupation in space all this time, taking images. I knew Sally Ride. She was doing some wonderful stuff up there, First Lady up there. And you think about these extra vehicle, the going out there in space. And it, an astronaut who works for my wife's company, he went up there and did some work. And I asked him, because when you drop something, it's going 22,000 miles an hour, pretty fast. And a BB at 22,000 miles an hour will put a hole through you. So I asked him if you ever lose a tool. His body jerked, and then he said no. I said, okay. So you don't want to lose things, but quite exciting. They say it's a view that you'll never forget. And so our international occupation and what we're doing up there is wondrous, to say the least, but we're not the only ones. Guess who else is in the business? There it is, those Chinese. And sure enough, that's their Tiangong, went up in 12. They're putting that together. And I had obviously, the privilege of hanging around with their Neil Armstrong, Major General Young, nice guy. His English was about as good as my Chinese, but we had a good time at a conference. And when the conference was over, because we were seated together, 10,000 Chinese came down on me. I had never been crowd swamped before like that in my life. He is their rock star, just absolutely. Now, a little closer to home, I'm very, very pleased to say that, of course, he's no longer here, Dr. Ed Mitchell. He was a sixth moonwalker and a friend of mine. And so I feel very privileged to have hung around with some of the greats. And the speed with which their whole experience of this came to fruition, that's him holding the controller, because Neil Armstrong told him, hey, before you leave, because he landed the Apollo 14 on the moon, and he said, take a screwdriver, and that's your joystick. That's what landed him on the moon. He said, take it with you. So he's got it in his house, and that was my touch of the moon, as close as I ever got to it. And he had his birthday. So his birthday is about a dozen of us there, down in Florida. And he opened up this card, and it played Happy Birthday. And I said, oh, Ed, what are you going to do with the card? And he goes, oh, I'm going to recycle it, Tim. I said, no, you're going to put it in the, it's okay, recycle it, whatever. But which had more computational power, Apollo 14 or the birthday card? Okay. Orders of magnitude, this card with which is going to be put in the bin for recycling. Now, how do we put our minds around that kind of rapid growth, that kind of exponential advancement, that potential for the human species? I personally don't think we can. And artificial intelligence is just right on the leading edge of that, and we're going so fast, folks. It's like put on the seatbelt and enjoy the rest of our lives, because it's going to go faster and faster and faster. And that's the world we live in. But I always found that to be an interesting anecdote, and now you can share that one with anybody you know, because that's the true and that's the picture to prove it. So, how are we going to make peace in space? Fortunately, we've got together with the United Nations, and being a former UN person, I like the idea that the nations get together and sit there and have the difficult discussions about how do we keep peace in space. We're not real good at it on the planet, but we work on it. But can we do it in space? And to do it in space, we've worked on a variety of outer space treaties and the outer, again, celestial bodies and how we're going to share the moon. All those things worked out in detail. So we're working on it. But every now and then somebody does something that's a little radical. Now, they tested a weapon, the Chinese, and they blew it into a bazillion pieces. Now, remember what I told you about that astronaut that dropped a wrench? Well, you got these things going around there. So space debris going 20,000 miles an hour is an issue. It is an issue. And they're not the only ones. I can't tell you some of the dark programs in the U.S., but I'll say the word laser is involved in it and kinetic is involved in it. So we won't go into all the details. But our side is also working very actively into how do we blast things. You've seen Star Wars, right? Everybody's blasting each other in space. Well, we're also working on that, and the Russians are working on it. The problem is, as we tested it, look what's out there. So you need your windshields fixed if you bump into these things. You know how that is, a little rock in the windshield. So it's a lot of it going on. It's a big issue, and there's a lot of research going into what can we do to fix this up. And the space station just moved recently because some of these things, they're monitoring them all, came within, maybe a couple 100 miles, but that's way too close when you're going that fast. And they're working on the development of such things as debris cleaners. How can we go up there with a hoover that'll get all that stuff? So we've in a situation that we didn't think about it early enough, so now we got some cleanup. But that's the human way, right? So what's to say? Now, other than this debris, there's these other things that we can bump into. And sometimes they bump into us. And when they do and they're big, we lose a few dinosaurs. But these guys are up there, and we're now landing on them and trying to see, can we move them? So the Japanese and the Americans have been working cooperatively with the Europeans to determine, can we land and move those? Hollywood's made a couple good movies about it, but we're actually doing that, and we're testing it out. So what have we got to offer now in this domain of who's the marshal going to be in space? So Marshal Dillon isn't around, but we have the Space Force. 20th December 2019, Space Force. They talked about it for over 20 years. Now we have one. About 10,000 people there on the staff, and they're like the Marine Corps. The Marine Corps is equal to the Navy and works with the Navy. The Space Force is equal to the Air Force, but works with the Air Force. So it's the sixth Department of Department of Defense. So interesting group, and there's the mission responsible for organizing, training, and equipping Guardians. I love it. That definitely sounds like science fiction. Guardians of the universe to conduct global space operations and enhance the way our joint and coalition forces fight, while also offering decision-making military options to achieve national objectives. Kind of ambiguous, but that's it. So there they are. Very exciting. Sempra Supra, always above. Now you know it. Semper Fi is the Marines. Semper Supra is the Space Force. So I personally thought I'd never live to see something like this, and it's exciting to me. It's an incredible experience for all of us, I think. So back to my side of the house, mission to planet Earth, Earth observation satellites. We've got a bunch of them there, and we've got something called the A-Train. So when people say, how do you know the planet's warming? How do you know the ocean's warming? How do you know this, that, and the other? Well, we have a bunch of satellites, and this is just one of them that's grouped together so that the precision of the measurements can all be calibrated and assessed. And so we get into atmospheric science, surface science, clouds, all kinds of stuff, and that's called the A-Train. And I was inspired by that, the A-Train, and I wrote a book for children called Satellites. And if anybody's interested, I would need your contact number, and we could communicate by email, and I will mail you a copy of that book, okay, if you're interested. It's written for 10 to 14-year-olds, but older people have enjoyed it too, and I don't charge for it. I just ask, if you want to pay for the shipping, that helps me out, but other than that, happy to share the joy. Because there's the A train that I translated for children to explain anthropomorphizing the satellites into fun characters, because kids like fun characters. So there we are. The space station is where they all hang out. The ISS Cafe, it's kind of like the World Cafe upstairs. It's all one gathering place for us to get together and enjoy each other's company. So once again, all kinds of satellites up there we see for the sun and the earth. We're monitoring the sun because it's an important part of our life, to say the least. And sunspots and monitoring sunspots, and I showed previously the impact of the sun and the solar flares, which creates our wonderful borealis, the northern borealis and the Australian borealis. It also provides sunburns and other things. But the sunspots can impact communications and can wipe things out, as they did back in the Carrington event back in the 1900s. So it's important for us to monitor the sun. And the Parker mission was recently, very excitingly, closest thing we've ever sent there. And it's showing us incredible data and information about the temperature of the surface of the sun and outside. And it always sounds strange to me, but the outside corona is much hotter than the actual sun. Orders of magnitude hotter. And it's like, why is this going on? All from helium, a hydrogen atom splitting into helium. And you go, wow, amazing stuff. So this one went up, and there's closest we've got, again, just last month. So this is timely stuff, folks. Good stuff. And only 93 million miles away. So a lot of research goes in there that our taxpayers pay for, either we all pay, and we end up going, yeah, is it worth it? I think probably so. I think the building up of the knowledge base is very beneficial to us, and they've got a continued future missions. This says just to 2020. Believe me, it goes farther than that, but it's a history of the missions that NASA has placed into space, again, notably with a lot of international cooperation. European, we even cooperate with the Chinese, the Indians. So it's that wonderful brotherhood of community of the planet. Now, who's got satellites? Well, I crossed that out because that number is changing all the time on the left. The 4550, nah, that's history. A lot of different places. You can see the Leo, Meo, and Geo showing that. And here's only 50 of them, all right? This is what's on the horizon now. Okay, Starlink. Who's involved with Starlink? And here we've got the Starlink. That's our friend. You see him in the news a lot. We might see some more about him. What are his ambitions? 6,426 satellites launched with a goal of 42,000. Is that more than others? It's more than all the others. Mr. Musk has more satellites than all the nations on our planet. Mind-boggling. And he's a civilian. So, we've got these other ones. Why even mention U.S. Air Force? They only got 87. They're nothing. Look at that. So, very impressive. I don't know how to put my mind around it. This guy from, he was an alien. He's from South America, right? He was, yeah, okay. So these are all the different places that have it, but we're number one, and we're number one thanks in big part to Mr. Musk, but these are all the different countries. So you go, oh, hey, everybody's got a satellite. Look in Africa, you go, what? Nigeria? What are these? Everybody wants a satellite. But they're so important in our lives. They're so integral to our way of life that if you start thinking about dismantling it, you go, well, wait a minute. every dimension of our life. Obviously, communications. You like your cell phones? Anybody here not have a cell phone? Come on. Earth observation, that's my domain. I love it. Technology development, navigation. Why is this ship? Otherwise you'd have Captain Eric out there with his sextant. Doesn't have to do that. Much more accurate. Technology demonstration, earth science, So this is all the different ways of our life that are implicated in the whole creation of satellites. Fantastic. And yes, there's one guy that's standing out. No denying it. No denying it. He's had a big impact. Now, as I said, he's from South Africa, so he's an alien. And who knows what that means?
Greetings, travelers. Welcome to Mars. Discover breathtaking wonders like Olympus Mons and Valles Marineris, sights to inspire your imagination. Glide in luxurious hoverpods, explore towering domes, and experience the thrill of Martian hospitality. On Mars, the adventure never ends, from skywalking to crater diving. Don't miss your chance to enjoy an unforgettable journey among the stars. Zorvif Klano. Tharvix Marsal Pu Trelix.
You might look to book a future Viking Mars. Who knows? And we hope they have the best interest for all of us involved, of course. So, just amazing where we're going with this world of ours. And again, because of the Earth science monitoring, I'm reminded of all the very wonderful things that we're using with it in the Earth observation system. So, my friend, old friend from the military, works with Kennedy Space Center, tracking the turtles around the world. And with these little tracking, we're tracking whales, porpoises. We're learning about the sea life. And for those that my next talk is about whales, in a lot of the things that we've learned about what's going on in the world has to do with our ability to track them around the world. So the space technology has been very, very beneficial to us in understanding and learning more and more. And the more we learn, the more we can understand, the more we can share that knowledge, and then perhaps do the right kinds of things to help us have a sustainable and a beautiful future for your grandchildren. And so, how much water is out there? Does California have problems with water? Well, we actually monitor very carefully. The GRACE satellite is one of them. It monitors how much water is out there with precision again. So we can use this technology to say, as opposed to, well, we're just haven't had much rain lately. Well, we can say how much rain lately we haven't had. How much rain is in the Sierra Nevadas? How much moisture? And with precision. And this is the information we need our decision makers to have in advance. Because as some of us know, the climate seems to be shifting a little, and we need to know as much information as we can to make the right decisions. Because if we're caught off guard, I think you looking in the news lately, we see what happens when you're caught off guard, and it's not a good thing. So we go and we look at the changes, the impacts of hurricanes. We all remember Katrina. It was a big one, and it changed what New Orleans looks like. And it changed our ideas that those dikes might be okay, because they're not okay the way they were built. So again, we learn, and now we can project. So it's so important, the satellites helping us get information to prepare properly for the future. Planning, proper planning. We can look at places like the desert where I used to live in Las Vegas and look at Lake Mead, which is drying up because it's overuse. So we need to manage our natural resources effectively to support the quality of our lifestyles that we all want to enjoy, right? Here's Las Vegas when I first went out there. Growing a little bit, growing faster. Fastest growing county in the country, 5,000 people a week were moving in there when I worked for the county. So, boom, boom, boom. There's the Amazon. The red is the green. This is the Amazon when it was lush and green, okay? Then somebody thought, let's build a road and cut some trees. That won't have too much of an impact. Well, it does. And so we're now learning that the lungs of the earth and we're measuring it so we can say with precision, instead of saying, oh, the Amazon's being damaged, we can say what's being done, and we can get together cooperatively with Brazil and Peru and others and say, what can we do to help you preserve the Amazon, the biodiversity, in a way that's meaningful for you, meaningful for the rest of the planet? Because before and after is a big shock, big shock. A lot of things are happening there that we wouldn't be able to understand and talk about unless we had these Earth observation satellites. So it's very important to make good decisions with good data so that we can have sober discussions, develop consensus on what might be the best path forward, instead of guessing or getting irate about this, that, and the other. This is the realities. So a lot of mining and things that are going on in deforestation, okay, now we know where to talk about it. We can target the issue. That's what you go to the doctors to get an assessment, to target if there's an issue, if there's a tumor somewhere, you want to know where it is and talk about it. So we need the precision. And then we can look at the effects of things like typhoons recently off of Madagascar. This is what a nice little angelic tropical place looked like. This is what it looks like after the typhoon. So these people were seriously impacted. You like to go out boating and fishing, there's your boat all parked. And then you look up and you go, hey, Ma, there's no more boat. So these are important in terms of ability to appreciate and monitor and map and measure so that we can perhaps manage our resources in a more proactive way, cooperatively, because this is the reality. Now, recently we set up the James Webb Telescope. I love it because this thing was spectacular, spectacular. Origami, this thing was all folded up, and I couldn't have been an engineer on that team. 10,000 things had to happen exactly right. Exactly right. And how somebody could make that, I'm in awe, total awe. They were able to unfold this thing exactly, right? And it's way up there. So remember the electromagnetic spectrum, it allows us to see across the electromagnetic spectrum from the highest place in our solar system. So you can see down the ground, all these things are connected. There's all our satellites. But the Webb is up there taking a look. And what it has shared with us is what Carl Sagan could only have dreamed of seeing, was billions and billions of galaxies. And you see those little things out there, squirrelies. Billions and billions of stars in there. So you go, okay, how do you put your mind around that? That's more sand than it's on the beach. You know, more than grains of sand on the beach is out there happening. So it's very impressive. I highly recommend that you share with your grandchildren and friends. You can pull this up on your big screen TV. You can zoom in. It's awesome. Just go to the Webb telescope. You can easily find that and spend an evening looking at it. It's also very calming. There's a lot of politics. There's a lot of things going on. LA, Syria, Gaza, you sit here and you have the universe now you're sharing with it. And it provides a very, very grounded experience. I highly recommend it. Glass of wine, spend that. It's as good as any meditation technique that I know of. Now, the Webb has showed us our planets, and right now, in the evening, we're going to have Jupiter, Saturn, Mars, and Mercury. So they're lining up. So for the next few weeks, you should be able to see a wonderful thing. And here we see, of course, Jupiter. And this is Saturn. And that was one of the first ones I saw at a telescope years ago, and it blew me away out of my own field telescope. You can see it, and it's a wonderful thing to see. The closest moon to that, Saturn's closest moon, is called Mima. Now, you can't make this stuff up. You wouldn't have believed me if that's really there. It's an ice moon, and tell me what it looks like. Absolutely. You can't make that stuff up. So it's so fantastic, no matter what we think, as we're getting views. And there we are, the Neptune. Turns out the Neptune's got rings as well. The Neptune has rings. It also has ships on Viking. right? And you're on it. So I hope you got that mental connection. James Webb Space Telescope, Neptune, Viking, fun, life, love, okay? This is where it all comes together. Galaxies, and not just one, a plethora, which is a whole bunch of galaxies in every way that we could possibly imagine. And you have direct access because of folks at NASA and Tim, when he was young, working to make sure you could sit in your living room and see it on your cell phone or watch it. That's why we gave you Google Earth and these other things, so you could sit there and look at it from the comfort of your living room, which is much better than getting in a can and going to Mars. From the comfort of your living room with a glass of wine, sitting there and sharing with your grandchildren and children this glorious universe that we live in. What a wonderful gift we've been given, and I'm glad I got to share it. Thank you.